In this video, we're going to talk about dilutions. So, what's a dilution? Well, a dilution is the process of decreasing the concentration of a solution by adding more solvent. So, if you think about this with Kool-Aid, I'm sure you're familiar with Kool-Aid, the solvent is the water and the solute is the powder. If I add more solvent, if I add more water to a Kool-Aid that's already been mixed, the Kool-Aid's going to taste pretty watered down. That's going to decrease the concentration. If I add more solute, more of the powder, it's going to increase the concentration. So for dilutions, we are increasing the solvent to lower the concentration. So one cool thing that we can do with dilutions, the volume can be in either milliliters or liters. So we're going to be using this equation right here. Molarity times the volume is equal to your diluted molarity times the volume. So this volume can be in either milliliters or liters as long as both volumes are the same. So in this first example, it says how many liters of a 2 molar NaOH solution are needed to make 1.5 liters of a 0.5 molar solution. Well, let's list off what we've got. So the two numbers that we can put together here are the 1.5 liters and the 0.5 molar solution. So our M1 will be 0.5 molar, our V1 will be 1.5 liters. M2, the molarity that we're trying to find here is 2.0 molar. V2 should be what we're trying to find. So let's list off what we've got in our equation. So remember, our equation is M1V1 equals M2V2. So we've got 0.50 molar times the volume, 1.5 liters, and that's going to be equal to M2, which is 2.0 molar times V2. We want to get V2 by itself, so let's divide both sides by that 2.0 molar. So notice I've isolated V2. So on my calculator, I'm going to do 0.5 molar times 1.5 liters, and then I'm going to divide that by 2.0 molar. If you do that carefully, you should get 0.375. We have 2 sig figs, 2 sig figs, 2 sig figs. So we want to round this to 2 sig figs. So our final answer will be 0.38, and our volume was liters, so this will be 0.38 liters. In our second example, it says, how many milliliters of 12 molar HCl are needed to make 250 milliliters of a 1 molar solution? Well, let's put some numbers together. So the milliliters and the 1 molar go together. So that'll be our M1 and our V1. Now remember, it's okay to put things in milliliters as long as both are in milliliters. So our M2 will be the 12 molar, and then V2 is what we're trying to find. So our equation is M1 V1 is equal to M2 V2. So let's plug in what we have. We've got 1 molar, 250 milliliters, and that's equal to 12 molar, and then we're trying to find V2. Just like the previous example, to get V2 by itself, let's divide both sides by 12 molar. So again, when we enter this on our calculator, we're going to do 1.0 times 250 milliliters divided by 12 molar. So when we do that carefully on our calculator, we get an answer of 20.833. In our question, we have 2 sig figs, 2 sig figs, 2 sig figs. So our smallest number is 2 sig figs. So we'll round this to, you guessed it, 2 sig figs. All right. For this third example, it says you need to make 0.5 liters of a 0.25 molar NaOH solution. So the question asks, what do you need to know? What quantity do you need to know? So remember, molarity is equal to moles over liters. We have the molarity, we have the volume, so we need to know the grams of solute. All right, to solve for that, let's plug in what we have. So the molarity is 0.25 molar. We don't know the moles. The volume is 0.50 liters. So let's multiply both sides by 0.50. When I do that, I get an answer of 0.125 moles. Now we need to convert those moles to grams. So 0.125 moles. NaOH solution, its molar mass is 40 grams per mole. So for every 1 mole, we have 40 grams. And our answer is 5.0 grams. In the third part of this example, it says how many liters of the 0.25 molar solution are needed to make 5 liters of 0.15 molar solution. Well, let's list out what we have. So the 0.5 liters and the 0.15 molarity go together. So that'll be our M1, 0.15 molar. And V1, 0.50 liters. M2 will be the 0.25 molar. And then V2 is what we're trying to find. So our molarity equation is M1V1, or our dilutions equation, I should say, M2V2. So let's plug in what we've got. 0.15 molar, 0.50 liters is equal to M2, 0.25 molar, V2. We want to get V2 by itself, so just like the other examples, we'll divide both sides by 0.25 molar. V2 will be after we do our sig figs, 0.30 liters. And that is how you do dilutions.